A complex quadratic polynomial is a quadratic polynomial whose coefficients and variable are complex numbers. Forms. When the quadratic polynomial has only one variable, one can distinguish its four main forms. The general form, where the factored form used for logistic map, which has an indifferent fixed point with multiplier at the origin. The monic and centered form. The monic and centered form has the following properties. It is the simplest form of a nonlinear function with one coefficient. It is a unique critical polynomial, i.e., it has one critical point. It is a centered polynomial. It can be post-critically finite, i.e., if the orbit of the critical point is finite. It is when critical point is periodic or pre-periodic. It is a unimodal function. It is a rational function. It is an entire function. Conjugation. Between forms. Since is affine conjugate to the general form of the quadratic polynomial, it is often used to study complex dynamics and to create images of Mandelbrot, Julia and Fatou sets. When one wants change from to, the parameter transformation is and the transformation between the variables in and is with doubling map, there is semi-conjugacy between the dyadic transformation and the quadratic polynomial case of C equals -2. Map. The monic and centered form, sometimes called the Duady-Hubbard family of quadratic polynomials, is typically used with variable and parameter. When it is used as an evolution function of the discrete nonlinear dynamical system, it is named the quadratic map. Notation here denotes the nth iteration of the function. So, because of the possible confusion with exponentiation, some authors write for the nth iterate of the function critical items. Critical point. A critical point of is a point in a dynamical plane such that the derivative vanishes. Since implies we see that the only critical point of is the point, is an initial point for Mandelbrot set iteration. Critical value. A critical value of is the image of a critical point. Since we have so the parameter is the critical value of critical orbit, the forward orbit of a critical point is called a critical orbit. Critical orbits are very important because every attracting periodic orbit attracts a critical point. So studying the critical orbits helps us understand the dynamics in the Fatou set. This orbit falls into an attracting periodic cycle if one exists. Critical sector. The critical sector is a sector of the dynamical plane containing the critical point. Critical polynomials. So these polynomials are used for finding centers of these Mandelbrot set components of period n. Centers are roots of nth critical polynomials. Finding roots of Mandelbrot set components of period n. Misiurovich points. Critical curves. Diagrams of critical polynomials are called critical curves. These curves create the skeleton of a bifurcation diagram. Planes. One can use the Julia-Mandelbrot four-dimensional space for a global analysis of this dynamical system. In this space there are two basic types of 2D planes. The dynamical plane, plane or C-plane. The parameter plane or Z-plane. There is also another plane used to analyze such dynamical systems, W-plane. The conjugation plane, model plane, parameter plane. The phase space of a quadratic map is called its parameter plane. Here, is constant and is variable. There is no dynamics here. It is only a set of parameter values. There are no orbits on the parameter plane. The parameter plane consists of the Mandelbrot set. The bifurcation locus equals boundary of Mandelbrot set. Bounded hyperbolic components of the Mandelbrot set equals interior of Mandelbrot set. There are many different subtypes of the parameter plane. Dynamical plane. On the dynamical plane one can find the Julia set, the filled Julia set, the Fatou set. Orbits. The dynamical plane consists of Fatou set, Julia set. Here, is a constant and is a variable. The two-dimensional dynamical plane can be treated as a Poincare cross-section of three-dimensional space of continuous dynamical system. Dynamical Z-planes can be divided in two groups. Plane for planes. Derivatives. Derivative with respect to c on the parameter plane is a variable, is constant. The first derivative of with respect to c is this derivative can be found by iterations starting with and then replacing at every consecutive step. This can easily be verified by using the chain rule for the derivative. This derivative is used in the distance estimation method for drawing a Mandelbrot set. Derivative with respect to z on the dynamical plane is a variable, is a constant. At a fixed point at a periodic point z0 a period p, this derivative is used to check the stability of periodic points. At a non-periodic point, the derivative, denoted by can be found by iterations starting with and then using this derivative is used for computing the external distance to the Julia set. Schwartzian derivative. The Schwartzian derivative of f is